A warm welcome to everyone and a special, really special thank you for spending your valuable time with us on such an exciting day. Today's topics are microservices, containers, API management, and integration. What an action-packed day. My name is Michael Carty. I am Chief Strategist for Red Hat Canada, and I'm going to be your MC for the day. I'm actually also running the expert panel, and I have a closing keynote today, so it's kind of like I'm the MC, and my initials are MC, kind of works out well. This is your day. There's a lot of rich content, ideas, notions that the various speakers will be presenting today. I sincerely encourage you to ask questions, participate, talk to other potential clients in the room, reach out to Red Hatters if you want to have questions. If you're shy, just come see me. But please make the most of your day today. There is a ton of dense content we're going to be presenting with some fabulous presenters. So maybe quickly around microservices, very hot, kind of the new hot buzzword. How many people are here today to talk about microservices or hear about that? Okay? Oh, we're relevant. How many people are here for API management? This gentleman's going to have his hand up, I think, the entire time. Containers? Yeah, okay, yeah. Good. And integration? Wow, excellent. We've been running these events now for about a month, and it's been outstanding attendance. I think Red Hat's been very clever in choosing strategies and products that are very relevant for the market. I know the Canadian business, we were the fastest growing business in the Americas last quarter, our Q2, and sustained growth of over 50%. So thank you so much for your time today. So microservices application architectures, how many people know who Gene Kim is? Anybody read the Phoenix Project? Yeah, Gene makes a claim in one of his presentations. He's one of the forefathers of DevOps and the DevOps movement. He says that application architecture is one of the key indicators of corporate performance. And I mean not just on the IT side of things, but I mean on the business side of things. He says that his team's research says that organizations adopting modern application architectures have a 50% higher market capitalization as a result of that. Microservices sort of break down the monolithic applications into sort of single-purpose, reusable services that are together compose an application and can really enable DevOps and the DevOps movement. Now, containers. Containers are a really hot topic as well. Containers simply solve the problem of moving software around in many ways by containerizing an application with all its dependencies, such as shared libraries, config files, etc., into an immutable object. So this allows the predictability of moving that software from a developer's workstation all the way through the non-production supporting environments to production, but also across public clouds if you're going from on-prem to public cloud. So it's been a highly adopted technology, I think, in the marketplace. Red Hat is a very, very different company. We believe in participation by all parties. We believe in meritocracy, or best idea wins, similar to peer review and research. We believe in transparency, and we believe in openness. We believe in the strength of diversity, collaboration, and sharing. And so much so that we not only invite individuals from outside our industry and even our competitors to collaborate with us. In fact, there are 33 million open source contributors worldwide, innovating within the open source ecosystem, in challenging the status quo, in changing the world. So why am I talking about ideology today? We believe that diversity and the sheer capacity of open source development models allows our clients to innovate much, much faster. As an example, the province of BC and its 27 ministries and partners have leveraged a Red Hat application modernization platform, we call OpenShift, to radically improve the delivery of major applications that historically took 3 to 4 years, are now being able to deliver digital services to its constituency in literally in weeks and sometimes days. So with that, I'm going to invite up our first speaker today, Maureen Fleming. Maureen comes from IDC. She spends a lot of time in the market talking around industry trends with regards to middleware, integration services, and application platforms. And we're so delighted to have her here today. We actually have a couple authors talking today as well, and we're really excited to have such a lineup to talk around some of the technologies that Red Hat brings to the table. So come on up, Maureen.
So I have the regular presentation I'm going to give you, but I wanted to start just talking about how things are changing right now in a significant way. I've been an analyst for a while, and I've been in tech for my entire adult life. And we've seen this trend, this cloud trend happen, started with, NetSuite and Salesforce, when they talked about no software and they were actually offering the initial version of SaaS. And then, and that was in the late 1990s. And then AWS came out with some beta for AWS in 2006. So we've been on this really long cycle of cloud. So even though I still go to events and talk about cloud in relationship to innovation, in fact, AWS is 11 years old. And Salesforce is almost 20 years old, in terms of having a product generally available. So really, it's not new, right? And what's happened as an analyst, I get to look at trends. And a year ago, we were on this continuum around cloud as a logical flow, right? Especially public cloud. There are a lot of organizations that want to do private cloud, but we were not seeing traction in private cloud, so we felt like the motion is always going to be toward public cloud and industry cloud and different ways to collect into these environments. And a lot of the vendors we talk to talk all the time about wanting to dominate cloud. And this year, it was really, there were some strange things that, just trends that sort of came into place. We ended up, I think that there was this general sense that things like private cloud on OpenStack was probably not going to be as easy as everyone thought it was going to be. So there was preference shifts, toward spending money in public. And there's also this thing called container platform. We've been hearing about Docker for a while. We heard about Kubernetes for a while, and then suddenly these things converged. And so, so everyone started talking about container platforms. And the other thing that happened also is that serverless took off. Lambda's been around for a while from AWS. It really took off this year. A lot of people are working on that. And the other thing, when you look at it from, if you move up the stack into the process tier, this technology called robotic process automation took off this year. And so it's not about doing business process management anymore, it's about doing RPA. And so there are all of these trends swirling around. And a lot of it, when you look at it, in my mind, it boils down to this focus on efficiency. So even though a lot of people probably in this room, and for me, there's a lot of talk all over the place about digital transformation and about being able to grow revenue, but all the trends that are really catching on right now are about this super high efficiency around cost. So stripping, at every layer, stripping cost, cost out of the mix by getting rid of inefficiency is a major theme. And that's changing some of the decisions that you're likely to make over the next year. And the acceleration on that trend is pretty dramatic, much more dramatic than the adoption of cloud over the past 11 years. And I also want to say that I have been working on different projects with organizations around planning and designing solutions. So I'll bring some of that in to start showing examples of what I mean by this cost efficiency that's happening. So we'll talk about, these trends and weave that in. And the first thing that I wanted to go into is that part of the thing that made the late part of last year, early part of this year really important is that public cloud finally is adopted in a mainstream way around the world. So, and by mainstream, we sort of look at where you get an adoption rate of about 50% plus. And in this case, we have adoption over that, and also far fewer people absolutely say they're not going to do cloud, and that was a big leap over the past year. And when we talk about adoption, it means that they either have a lot of workloads in the cloud, they have some workloads in the cloud, or they're actually developing and plan to have them, within a certain amount of time. And what happened? And this is a big leap from the previous. And this is built on survey data that we do every year. A worldwide survey. It has about 11,000 respondents, so it's a pretty reasonable size. But when you start getting into mainstream, the behaviors change about what's happening in the cloud. And I see that with the projects I work on, the inquiry I get with clients. And I think up until about a year ago, the cloud was very much a place where you experimented. You either adopted SaaS, and you replatformed a big enterprise app onto one of the application clouds. And for on the bespoke side, you were doing projects that were largely experimental to align with like a digital transformation strategy or something. What's happening now is that companies are moving mission critical workload into the cloud. And so the decisions that organizations are making right now are much more serious and much more organized than what we saw up until about a year ago, where people were, development teams were making a lot of their decisions about where they wanted to run these experiments, and then focusing on how to operationalize them for when they ran them. Now the decisions are they're going up and down an organization, and business is involved, but they're not necessarily totally controlling, especially where they're going to put bespoke applications. So this era of moving to mainstream cloud is bringing in really important workloads into the public cloud for organizations, and that's creating a whole another set of problems that organizations have to deal with. And also, by the way, if you look at it, I did the cut of data on Canada, and I will say that with Canada, you have a higher adoption rate, 69%, compared to the world, 53%. And on top of it, Canada has more cloud experienced enterprises, and that means that they're running multiple workloads in the cloud at 47%. So which is about 15 points lower worldwide. So you're in this room with, my assumption would be a more mature mindset about public cloud. And on that note, how many of you are in the cloud right now with workload? Any kind of workload? Okay, that's actually a lower percentage. So than what we have. The other thing is that there's been a significant change in posture or mandate. A lot. I don't know. So, how many of you work for an organization that sort of says this is the mandate, like you must do this. So right, and right now it used to be that the mandate was no cloud. That was the dominant model. Like you have to have cloud by exception, and but we've seen this really dramatic growth to cloud first. So once you have if you when you look at the survey respondents who work for organizations who are running workload in the cloud, they have substantially increased their cloud first posture, and that is also a major trend. And it's not just for new workloads; it's for replatforming as well. And so it's not quite mainstream yet, but it's the most significant mandate for organizations that have cloud, they're running cloud. And then cloud also is also, pretty high. And those numbers went up about 15% compared to last year's survey. So once people have some success in cloud, they have more of an all-in attitude for where they want people to run, different applications. And again, so I'll do Canada. And you guys are a lot more conservative. So you're on the cloud more than the rest of the world, but there's still more choice. Only 25% of the Canadian respondents had a cloud first posture, and 40% cloud also. So those are more coexistent as a strategy and less cloud first. So So there's a little bit of conservatism or choice, however you want to look at it, in Canada relative to other countries. Then the other thing is, where are people spending their money? And also, by the way, I forgot to say, if you guys have any questions as I go through the presentation, then you should ask them or shout out, because it makes it more fun. This is a small enough group where, you know, we're not in this like big stadium or thing. So if anyone doesn't understand what I'm saying, doesn't agree with me and wants to argue, that's cool. And, you know, and has, you know, and just wants to make a comment, then.
When you say cloud, does that include on-prem cloud?
Public cloud.
Only cloud.
Yeah. So, you know, the first part of this is on the public, and now we're going to start talking about, you know, cloud architecture and where it's deployed. So in this case, we also asked respondents with where they plan to spend their cloud money. So this only goes to the respondents who are, you know, invested in cloud. And what was really interesting about the survey this year was that more money is spent not in SaaS, which is the largest category, you know, applications in the cloud, you know, packaged applications in the cloud, the equivalent, is typically it is the largest spending area by a lot. But more organizations were planning to invest more in custom applications. And so with this, you can see SaaS is 32%, but PaaS is 25%. So implementing a custom application in a native cloud PaaS tier is 25%, and hosting on infrastructure as a service 27%, and then private PaaS 16%. The thing that's interesting about this trend, there's a couple things. One is that people are moving mission critical workloads to public cloud, right? That's what you can draw from this. And chances are you're going to be working on projects that, you know, may originate locally, you know, where you're developing, but the deployment will be ultimately destined to go to cloud in some deployment model. And so you know, that part of it is pretty important to think about. And so I want to go into this next section with a little bit more detail to cover some trends. Every single tier of that you invest in with cloud, whether it's a SaaS tier or whether it's PaaS or infrastructure, there's custom development that's going on in all of it. You know, companies rarely, unless they're in a pretty small organization, they rarely implement a cloud application without doing some extension or not necessarily customization, but mostly extending. And so all the major cloud providers have their own their sort of proprietary paths. That's the domain for where you actually do the extensions. Some organizations make a decision that they're not going to use that, and they go outside and then they connect in some other way. But by and large, organizations that are adopting something like a Salesforce or, you know, one of the Oracle applications, they will use the environments that are offered by Salesforce or, you know, in order to build them. And what ends up happening is that the development experience is different in those environments. You know, clearly you're going to be working on data stuff, right? And migration and all those other things. And integration and connectivity. As a matter of fact, SaaS adoption drives the purchase of integration software, integration cloud software. And it's almost, you know, inevitably you're going to be investing when you see people adopt a SaaS application. And they also use things like workflow, you know, different workflow tools or mobile development environments in order to extend the capabilities of the core application. And that's where you start getting into development. What's interesting is that most of them have low-code environments where they're either called low-code or high productivity, where you're doing modeling, visual modeling and visual point and click, and you're building systems that way. So from that perspective, it's not really, you know, coding. It's more configuring that goes on with that. And so there's a whole raft of development that's going on in that category. And it's one of the fastest growing categories of middleware as well. And the other thing that is also, you'll also likely be involved with, the other way that people are extending it is by extending it through AI capabilities like conversational computing. They call them like digital assistants and things like that. So a lot of the vendors are offering services that are things like visual recognition, text recognition, text to speech, and all things that are backed by some sort of artificial intelligence that get called as part of the development and then is available in the user interface of the application. So those things, chances are, because it's a big category, some people in this room will be on those projects. And so in a way, you have to think about whether you actually want to do that or not, because you lose your coding skills to work in this high productivity environment. But the high productivity environment has its own virality inside the organization because it's so fast to use some of this stuff that you end up doing more and more of it as a developer. So it becomes your next lifestyle, if you get assigned to these sorts of projects. So because all of them are really optimized for speed. And the other thing that's happening is that all of the different applications have a whole set of APIs, and so that's the other the other piece that people frequently work on is that connectivity between two or more assets that are running across two or more clouds. The other thing is with PaaS. So PaaS, when people think about developing in PaaS, a lot of them, especially, a lot of people think about, well, I'm just going to custom code. So I'll, I'll do a Node SDK and build on top of that, or I'll, do, whatever framework you're planning to use or programming language you're planning to use, then you just build everything from scratch. But that's absolutely not what happens. When you're building custom solutions, a lot of organizations, they don't really want the development team to create products. They want the development team to implement a solution. And so there's a mix of PaaS native services that are used, including databases, integration and API management, reporting, and workflow, and on and on. There's a list that's common when I work on projects with clients where they're trying to re-platform to cloud. There could be 10 different services that you put together that need to sort of work well together, and then the part of the development is writing what's custom, and then the rest of it is implementing against what the game plan is, which is, by the way, the same thing people do in the enterprise. It's traditional. It's sort of the same sort of thing. Most people don't build an entire system entirely from scratch. Hopefully, here it's not really common because it's sort of hard to maintain. So what ends up happening with the spending is that they expect 11% of their investment's going to go to developers to actually build a solution, and the rest, 14% out of that 25, is to use commercial, services. What's interesting about this is that there are a lot of companies that haven't been in the cloud in a serious way moving into cloud, and they really don't want to build everything from scratch. They want to use the cloud offerings from commercial providers, and when you start and a lot of times, at least for me, this year, it's been a crazy year. I seem to have mostly people who've never been on the cloud before. And the first thing that we deal with on these things is getting in a big fight about which cloud to use. And not me, they're all fighting amongst themselves. And sometimes that takes longer to make that decision. The fighting, they might have a 3-month or 6-month window to get the project into production. And by month 4, they're still fighting about which cloud to use. And so one of the things that I work with them on is figuring out, looking at what the solution needs to be, and then mapping the PaaS services into each cloud stack to figure out whether there's a complete set of solutions and that there's choice so that you are not locked into a single vendor. And it's an interesting exercise because what you realize is that, that there's very little choice compared to what you had, when you build applications on-prem. So it seems like there's a million vendors that are in cloud, but when you organize it by category, there are very few vendors per cloud stack, per cloud offering. And you get to the point where you get gaps in capabilities. So I worked on a project where they were trying to decide whether to do Cloud Foundry for private or AWS for public. And they couldn't even build the solution using commercial software on Cloud Foundry because it was too gappy. And so these sorts of projects, it's important when you are having the opportunity to work on a project in the cloud and you're seeing this debate happen, is just to figure out your solution design and the products that fit the solution design, map it to each cloud, and that ends the debate. So I've done this several times now, and the debate, it becomes clear which cloud you have to pick if you value choice and you don't want to build everything yourself. So that's one trend. The other thing is that business sponsors, I want to just go into this one. Business sponsors view risk way differently when they're moving mission critical workload than developers. And so with experimental stuff, the nuts and bolts of things they're not so, they might be sponsored by the business, but they're not driven to make a decision by the business. But when you're doing a mission critical replatforming project, business is involved because they view, like if you work with a development team, and they say, hey, we want to do Kafka and Lambda, right? Then the business person says, okay, where's your experience in that? And if there isn't any, then they view that as ultra high risk. And so there's a pushback or debate that goes on. So if you know that you're going to be working on projects that are going to be deployed in the cloud, and you want to work with technology that you've never been able to work with before, it's important to put a little R&D into it to get some initial POCs, proofs of concept done. Because when you start having important things that need to be done quickly, you have business more involved on a replatforming type of project, and they have no appetite for risk, technology risk, and both tech risk and developer risk, because they view those as causing delays and adding cost. So it's important to plan ahead for different motions that you might want to work on as a developer, to make sure that you become the expert before you propose that you become an expert after the funding happened, because you're going to get mostly turned down at that point, and then people will go to more traditional cloud software, and it's sort of depressing for some people. And then I have to be mean a lot in those projects too, like saying, where's the experience, and so people like me or consultants who come in, you can't just let people do things from scratch on a mission critical changeover. So the other thing that's interesting too, in the replatforming in particular, pretty much people who are building new are building microservices. People who are building new are also using APIs or managing APIs. So they go hand in glove. If you're going to do a microservice, you have to do API management. It doesn't make sense not to, or at least an API gateway. But the other thing that a lot of organizations struggle with is to change the relationship of the back end and the front end, to create a relationship between the user interface or the front end of the application and the back end. And so, so there's also this move toward figuring out how to replatform into a separation because it makes it a lot easier to build really good UI and also build mobile UI and treat all of the backends as services that have APIs attached to them and create the communications between each other in that way. So that's really a major, that's been around for a while as a trend, but it's a dense trend, and companies struggle with that to figure out which applications are worthy to be replatformed in that manner. The other piece, I combined the private paths and infrastructure as a service because they're kind of related. So 43% of new cloud spending will either be hosted in infrastructure as a service or it will be built on private paths. And the reason I'm saying they're related is that the application, if you're going to have a modern application hosted on a cloud, you had to modernize it somewhere, right? You're not building it in paths, you're hosting it. So you might be using an AMI, maybe, but that usually counts. So you might be doing something like that. But what's happening now is that with containers, a lot of people are sort of using that, the container platform as their atomic unit of cloud in their data center. So they have like an existing infrastructure, bare metal or virtualized, and they're now starting to build their applications on a cloud platform on existing infrastructure so that they get the benefit of cloud architecture and they get the benefit of a late decision about where to put it once you deploy it. And so when you look at the 43% of new cloud spending, if this remains consistent for our next survey, then our assumption is that 43%, most of that will be built and delivered on a container platform rather than just built traditionally and then somehow hosted. And so it's important to start really thinking about what a container platform is and how we'd use it. And essentially it's, if you're replatforming and part of the replatform involves developing microservices, then that's kind of what you're thinking about using the platform for, to host the logic and the different microservices that you're using to build a custom application. The benefit of putting it into a container is that if you're in an organization that's fighting about cloud and what cloud, you can start your work, right? Because you know that you can deploy your container in any cloud that supports, the same architecture. So you can get going right away. The other thing is that you also can start planning for multi-cloud options. I had a client that adopted a major SaaS application, and they had 600 endpoints communicating with that application, and some of those had to be migrated with that application just because of co-location reasons. And there was no way for them to do that. They couldn't execute because they had nowhere to put these applications. So then the cloud becomes the container platform becomes this unit of co-locating applications with the SaaS applications, and it improves performance. The other thing that's happening with container platforms is, I said before at the beginning that there's this trend toward massive high efficiency. And a project I did, we decided to, I was working on a replatforming project, and the goal was to implement it on a container platform. So it was a replatform, to the container platform, and then it was a lift and shift of that to the cloud, to a public cloud. And so when we started working on it, the nice thing about replatform projects is that you have all the statistics you need to figure out before and after. So your utilization rates, your transaction volumes, and so when you go and talk to vendors about what it's going to cost, to adopt their particular software, instead of looking at the number of CPUs or cores, what you look at is you use your transaction metrics that you have from your replatform, and you get quoted on that rather than someone saying, oh, I run this application currently in 40 cores or 180 cores or 200 cores or vCPUs or CPUs, whatever it's counted. What you do is you look at the transaction data to get the quote, what's happening is that you're collapsing your cost on it. So, when you apply cloud architecture to existing projects for replatforming, you're working on something that goes from a very inefficient workload that's designed for inefficiency to a highly efficient workload. And an example would be, most of you probably run applications that are built for peak time, peak seasonal time. So it's high watermark plus 20% additional capacity. And so when you start comparing that with idle time, sometimes your idle time is more than your peak time. I mean, almost all of it is. So the difference between that is your inefficiency, your cost inefficiency. And so what ends up happening, if you moved it to cloud, you'd get a similar benefit. But let's say that you scale for a seasonal app, and during a week you hit 24% of utilization. That difference between your high scale and the utilization rate is completely wasting money. You're wasting so much money. And once you start working on using, building an application on a container platform, you get auto scale, you get cloud behavior just on that container, and your costs collapse. And that happened to me in a project I worked on this summer, and I was really nervous about the findings, the conclusion, because we didn't do a POC, we did a model to begin with, and so I thought, oh man, this is bad. But maybe I'm giving them bad advice. It was pretty scary. So I started checking around, and it's a consistent thing. I was at a presentation from a big telco, and they were doing the same kind of replatforming I was involved with. They were halfway through and at 50% reduced infrastructure. And a lot of, and mine was more than that, and so costs collapse accordingly, even if it's built on hardware, because you have all sorts of things that just go away, including licensed software costs. So the advice on this one is that if your organization is not in public cloud yet, fine, still do a container platform, because eventually they are going to want to go to public cloud. Do a replatforming project. If you have any give at all on a project, do replatforming onto a container platform, because it is shocking, what the cost basis, the changeover, and it allows you. For my project that I worked on, it was literally free. All the software was free, and then they still saved 50%. So I'm just, this for me is why it's disruptive, and it's disruptive too because when you are working on making a decision about which cloud, if you're on a container platform, it's not such an important decision. You move it as you need it to move. It deploys where it needs to deploy. So you've got, for the first time, since the cloud cycle began, enterprises have more control over their decisions about where they're going to put their stuff. And that's not been available to anyone since cloud began. So I just think this is an important topic. Does anyone have any questions about it? Okay. The other thing is, I said before that you have to pick what cloud. Application clouds, there's no one cloud that's going to rule them all, right? There's not. Businesses make choices based on capabilities that are in a cloud. It's up to IT to worry about how to make things work well between clouds. Bespoke is more of a standardizing effort. So Bespoke, Amazon owns 51% of where you're building custom solutions, and Microsoft on Azure is about 19%. And and then the rest of the vendors, somehow I lost all my other vendors. So IBM is about 7%, Oracle is less than 1%. And so when you look at Bespoke, the large vendors in Bespoke are the tiny vendors. In traditional are now the tiny vendors in cloud. So most of you who are going to build something are probably going to be putting it, if you're not locked into a particular co-location decision, you're probably going to be building it on Amazon. And when you start looking, I told you earlier, when you do the work to understand why. It's because there's tons of choice for software. Java, vendors that build on Java put it on AWS, vendors that build on .NET, the ecosystem, put it on Azure, and there's tons of choice, and there isn't choice pretty much anywhere else. It gives you vertical lock-in for most of the other solutions, and that's why that's important. But the other thing is that once you are in cloud and you support an application, chances are within 3 years you'll have 3 applications on 3 different clouds. And within that time, you're going to have multiple applications on either Azure or AWS. So that means that you're dealing with this idea that you've got 8 locations. You've got your data center, you've got where you're hosting your legacy stuff, and you've got those 5 or 6 clouds that you're dealing with. And that creates a whole level of complexity around how to handle decentralized infrastructure, what's essentially a decentralized architecture that needs to basically flow all between the different systems. So that's what we'll talk about next. So what ends up happening is that integration and connectivity software become really important in this decentralized environment because in the data center 10 years ago, almost every application had to be integrated in some way. And we've been on this sort of composite or composition-oriented design for a long time. And just because it's in the cloud doesn't mean that the integration requirement goes away. It just gets a lot easier from a connectivity, but slower from a speed issue. But using API management, building integration between the different cloud assets and messaging become really important. And the other thing is that you build different assets. You build a catalog of services that are yours, that you build your bespoke assets, and then also you have a catalog of the third-party applications that you use. And so you're connecting via API. Chances are you're using integration not in an enterprise service bus form. What you're doing is you're creating applications that by nature integrate. So you're building an integration application with its own API that could be called by anyone who has rights or any system who has rights to get to that integration application. And it's defined and you understand why you're connecting to it. So that is a significant trend that's happening in the market now. It's just this, the collapse of the ESB to these integration applications. The other thing that's happening as people move to microservices and they deal with integration is that they're thinking more along the lines of handling transformations and those sorts of activities as a microservice that's embedded in the application. So you have effectively a dumb pipe and a smart endpoint, and the endpoint handles integration as a set of activities that are the responsibility of the application and not this third-party system. So again, another reason why ESBs are starting to they're not coming up in the cloud. People are not building those in the cloud, and they're also that's a big trend for private is to get rid of ESBs and move into this application designer, application embedded design. So just wanted to talk about that piece. And the other piece, we talked about the sprawl that people are dealing with. This diagram looks at, the amounts, the things that have to be connected. You've got people building IoT solutions that are at the edge. You've got data center, you've got cloud, you've got all these things. And what happens is that you have development teams picking their own solutions. Like if you're building a microservice on Azure, a microservice architecture application on Azure, use Azure API Gateway. If you're building on AWS, use AWS API Gateway. And so all of a sudden, you're building these high-value assets on different integration products or integration and connectivity products, And no one has any line of sight about anything except for those individual development teams. And so what's happening is that there's incredible pressure, to be able to gain that line of sight. And it's changing how organizations are selecting their integration suite or their integration software, to the point where it's not that you're replacing all this stuff. You're not replacing the API gateway, AWS API gateway, or the Azure. What you're doing is using integration to connect to that, so that you have, you can share assets via the portals, via a portal that you might deliver, that's part of the API management, and you're also integrating with those directly. And so it's changing how you're selecting integration software to have it focused on integrating with third parties. And chances are all of you in this room are going to have this issue. And if you're fortunate, what you'll be able to do is make decisions about multi-cloud standard selections. So being able to pick the same gateway that you use everywhere because it works across multiple clouds. And being able to do the same messaging because it works across all the clouds. And it's important. But a lot of people didn't have that choice 2 years ago. And you may have that choice. It's the best thing to do, but it's not what a lot of people have available to them for choice. So it changes your selection criteria to make sure that the ones that you pick can communicate and connect with other things that they might compete with. So that's another major trend. And on that, some recommendations. So I said before, build a POC on the container platform. Especially, you can, if you're working on a project that's tied to digital transformation, or you have this opportunity to re-platform, you can build the business case off of that first proof of concept. I know that for me, with some of them that I've involved with, they've taken that first concept and extended it in the organization because they can afford to do more because they save so much money. So it's a good thing to build the business case with the initial POC, and also making sure that you get when you work with the vendors that you're evaluating, to bring in to deploy the software on the container, it's really, really important to negotiate based on your understanding of utilization and peak capacity, and not on the number of cores that you're running, because you're going to be overcharged and you're going to be running an underutilized container platform. So you want to definitely do metrics-based decisions rather than having them say, well, how many CPUs are you running? And you tell them, and they give you a quote for that many CPUs. Don't do that, right? And then the other thing is looking at, really start figuring out how decentralized you are, or how likely you're going to be decentralized. How much of it is a problem now, and how much of it will be a problem, in a 18-month window, and then start planning, thinking through who you want to partner with on the integration front to manage decentralization in a graceful way. It's not the easiest thing in the world to do. There's like 20 vendors that do integration. There's only a couple who figured this whole hybrid piece of it out in a really good way. So, and then also rethink your ESB. And then the final thing is that if you're building APIs, especially high-value APIs, they're your digital utilities. If you're building an integration application that's available via an API, you've essentially created a utility that everyone can use. Those are products, right? You're building products for use by your partners, by your customers, internally, and they need to be managed like products. And so that means that your team has to be responsible for security, for hack, where you find a security breach, you have to fight it off, build it. You have to manage the life cycle of the API and the versioning. So the whole thing, you become the product manager of that API. And so then you become known as that. Your documentation becomes important. And if for those of you that have, it's a great thing. For those of you that haven't, it changes the behavior because it's not implement and walk away and it's someone else's problem. You own the problem. And, but then you also own the metrics on reuse. So a lot of organizations are now starting to measure reuse, and the teams that manage highly reusable services become, they become known for that. And so it becomes your reputation in the business as long as you're the product manager of that API. So on that, I hope it's my last slide. So any questions? I know I'm probably running late, right? Okay, any questions about this?
So at my company, the biggest obstacle towards migrating to public cloud is security, saying it's insecure, we don't want to give control. What do I tell them to make them?
They're wrong. Other than, you're just plain wrong. So the survey, I didn't put it here, but one of the top reasons why people don't move to cloud is security. And one of the top reasons people move to cloud is security. And, and so it's because, like, I remember talking, there's this software company called Box, and I talked to their CISOs, their team, and they had more people in, this $200 million company had more people working in security just in the operations side of it, not even the development side, than all the major banks. So, if at the end of the day, if you start thinking about security, there's two things that are important. One is that you do not have the same resources that a cloud vendor does at every level of the cloud tier for managing security and handling security and preventing. So the attack, so when you think about AWS, I've talked to companies that have moved to AWS, and they have this attack surface because of that. But they haven't, so there's more people trying to hack in, but there are more resources to prevent the hacking in. And when I talk to clients about this, and I'm not a security analyst, but it's like, really, right? Tell me what you're doing that's more secure than when you look at what's happening with the cloud providers. The other thing is, I've talked to organizations, especially SIs, who are building on containers. They're starting to implement this micro container concept, which so it's like a child of a microservice, but it allows you to, when you're doing a sort of some kind of change, you're basically breaking the path. So if someone hacked in, and then that microservice expires or it's updated, it breaks them from coming in back on that route. So this whole idea of using smaller and smaller code and making that available, it reduces the attack surface on the application that you build. And so applying that to cloud that you can do on your own, and then looking at cloud and thinking about how they secure differently from how you secure usually is persuasive. And I work with government agencies who are moving to cloud, right? Who should not be, if you thought about it, if it really wasn't secure. So it's one thing if you are a military unit or something, but otherwise there is a lot more protection than you think that in the cloud. So it's worthwhile to do more work on that topic. Oh no, you're going to ask me a question? I can't answer it.
So you mentioned at the beginning that there's obviously now we've gotten over 50% of companies that are in the cloud in some form. And so they are, how are they making the choices of where to start? So we often get that question, it's like, well, we need to do it, we know we need to do it, we want to do it. How do we pick what types of things go first, if you like?
In terms of the order, so for me?
No, well, in terms of migrating to the cloud, either your perspective or what you're seeing.
Oh, this is a big debate. This is a big debate, right? So some people say, let's just build it cloud native, right? And so they say, how stupid is that to do anything but do cloud native? And then now, and that's sort of been the pattern for for a decade. But now, there's more people thinking, how stupid is it not to build it in a container first and then have choice? And so there's a debate going on. So if you're AWS or a consultant working for on behalf of AWS, they're going to tell you, how stupid is that? Just go native. But that locks you into AWS, right? And if you're someone like Red Hat, you'll say, how crazy, just do it in a container. And you just have to think about, for you, whether you've already standardized on AWS, for example. If you're all in on them, then you can make a fair decision based on performance and the availability of software, either in the cloud or in the container. If you're not quite sure, then you basically, to me, anyone who's moving to the cloud, they get into these really heated debates about which cloud to pick. And it takes so long to reconcile that it makes more sense just to start building the stuff somewhere. So to me, the container is where you start, right? You pick a container platform and you build there. You let everyone fight it out, and then you just move it once you've decided where your destination is. So that's at least for me. But it is a hot debate right now.